this is my visual aid that I'll be using. It is just a very simple paper airplane, but we're going to be discussing the 4 fundamentals of flight, so I thought that it would be very appropriate. Alright, and now into the speech. We've all looked up at the sky and watched as a massive airplane soars overhead. A marvel of modern engineering that seems to defy the very laws of nature. How is it that a machine weighing hundreds of thousands of pounds can lift off the ground and travel thousands of miles through the air? The answer lies not in magic, but in a delicate and powerful ballet of 4 fundamental forces. Today, I'm going to pull back the curtain and show you how lift, weight, thrust, and drag work together in a beautiful and precise process to make flight possible. First, let's talk about lift. This is the force that directly opposes gravity and is created by the plane's wings. The unique shape of a wing, called an airfoil, and these are going to be your airfoils right here, causes air to move faster over the curved top surface and slower underneath. This difference in air pressure creates an upward force that literally lifts the aircraft off the ground and keeps it in the air, as we know from airplanes flying. Next is weight, which is simply the force of gravity pulling the plane down toward the earth. We also call this force load factor. This force is constantly at play, and for an aircraft to fly, the lift generated by its wings must be greater than or equal to its total weight. This includes the weight of the aircraft itself, the fuel, the cargo, and all passengers. So anytime that you're in flight, you're going to have lift, which is pulling you up, and then your gravity or your load factor, which is pulling you down. To move forward, an aircraft needs thrust. This is the forward pushing force generated by the plane's engines. Whether they are propellers or jet engines, thrust is what moves the aircraft fast enough to create the necessary lift and to overcome the final force, which is drag. So, on our single engine Piper Archers that we fly at Spartan, all of our thrust is generated by the propeller all the way up here spinning, right? On the big turbojets, normally they'll have turbine engines that are either on the wings or close to the rear that will generate that thrust for them from the backside. Alright, and then let's go ahead and talk about drag, and then we'll get into how these 4 forces act in stable flight. So, finally we have drag. This is the force that resists the plane's motion through the air. It's essentially air friction, and it's caused by air molecules pushing against the aircraft surfaces. Designers work hard to create sleek aerodynamic designs to minimize this force, making the airplane more efficient and faster. Right, so as we've just discussed, we have lift and weight, which are going to counteract each other, and we have thrust and drag, which are going to be counteracting each other. Now, whenever you're in stable flight, lift and weight are going to be equal because you're not gaining or losing altitude. You're simply at an equilibrium. And then thrust and drag are also going to be at equal because they're also at an equilibrium. And so yeah, so now that we've broken down the incredible process of flight into our 4 core components, the upward push of lift, the downward pull of weight, the forward drive of thrust, and the resistance of drag. It is the precise balancing control of these 4 forces that transforms a static piece of machinery into a soaring vessel. The next time you look up and see an aircraft, remember that what you're witnessing isn't a single action, but a continuous and dynamic dance of these 4 forces working in perfect harmony to carry us across the globe. Thank you for your time.